Hello there, welcome to an explanation to this interesting question. And we have y equals a half to the n. And obviously we're used to seeing something different. So we're used to seeing x cubed, and you will differentiate. And that's a power rule that we use. But here, something slightly different is we have a constant term, sort of a number, to the power of the variable, which maybe you use x, which is what you're used to seeing. But obviously on my channel, I can't use x as a superscript, so I use n. And this is a strange format because the power rule doesn't apply. So problem solving this on the spot, you might, in the exam, try a number of different things, such as realize that the variable ought not to be up there as an index, but brought down. And the only real way that we deal with that in sort of mathematics is we use the logarithms. So I'm going to use ln because it's such a easy one to use and write. And then you know the rule with logarithms that says that this can go down the front. So if you have an exponent with the number here, then it can go down the front. So our next row, in fact, I'll leave that there. Same on the left, but now we have in ln a half. Ln of a half is a little bit of a pain. Now we could do it as ln 1 minus ln 2, but I prefer to write it as, but remember that 1 over the reciprocal means to the power of -1. So as a index -1. Now that thing can go down the front as well. So we've got ln y equals negative n. That's the university way of writing ln. You might put it together. 2. With all of this in mind, we're kind of ready to differentiate. But before we do, I need to show you what's going on here. This is our y, and this here is our x, I suppose, but our variable. So what we've got on the right is actually a number. So not to let it confuse us too much, we've actually got ln y equals negative, if we put it in one bracket, nice square one, negative ln 2 n, knowing that that's just a number in front of our focus variable. Now we're going to differentiate with respect to n. The best way to do this is known as implicit differentiation. So we start with the left-hand side, and the derivative of ln variable is 1 over variable dy dx. And that's equal to, all of that just a number, and so it remains negative ln 2. Because in the case where we had 2x, that would differentiate, so the variable disappears and the coefficient remains. In this case, this is the coefficient. So we multiply both sides by y, so we'll get negative ln 2 multiplied by y. Having a y in here is a problem, so we'll try and find a different definition of y. This one is not the best to suit what I'd like, so I'm going to change it to 2 to the -1n, which is 2 to the -n, because you've got that rule where you have brackets and the indices will multiply. Bringing that all the way down, and in here, this final form. Okay, that's good. And, well, you can rearrange that if you like, and I think the format in the answer was where we have the 2 to the -n at the front, multiplied by ln 2. And that's how you differentiate that bit of an awkward function. Interestingly, if you notice that this here is the definition of the original function in a different format, then you'll see that down the bottom, you've got the original format here. Okay, and then we're going to be, it's like multiplied by ln 2, and it's always ln of the base, and it can be generalized. So it might be worth having a quick look at that. So suppose we've got y equals a to the x, and we apply ln to both sides, and we move the x down, and then we differentiate implicitly. This becomes ln a, and then dy by dx is equal to y ln a. And obviously we get rid of the y and we'll put back in what we had. So dy by dx equals a to the x dot ln a. If you're generalizing this, you can see that there is the original function, and that also this is ln of the base of that original function. So you could jump straight to that, couldn't you? Right here, if I had y equals 3 to the x, for example, then I could say that it would be dy by dx is equal to 3 to the x, which is what we have there, multiplied by ln of the base. And it's a wee trick that might be worth knowing for the exam, but as you can see, you can game it on the go. And that's the beauty of maths. It all makes sense really if you just figure out as you go along, one thing leads to another. You've got to have the confidence though. So hopefully this gives you some inspiration to be spontaneous and trust yourself in your own exploration. Instead of wondering or worrying or holding on to what someone else, what you think the answer should be, find your own way and go on an adventure.